Today we're going to talk about scatter plots and how we can maybe estimate an equation for a line of best fit, and then also just some other things about graphs. So if you have a parabola, how that vertex can tell us about the maximum or minimum value of a function, and then just really what things like x and y intercepts mean. So the first thing we're going to do is look at a scatter plot, and like I said, we're going to use that scatter plot to estimate an equation for the line of best fit. So one thing that you do want to make sure that you're aware of when you're doing something like this is that it is an estimate. So if you're trying to look at multiple choice answers and yours isn't matching up exactly, that's okay because you're just estimating what that line of best fit would be. The other thing to kind of keep in mind is that your scaling isn't always going to be counting kind of 1 unit over and 1 unit up. You can see here that my x-axis has a gap of 100 while my y-axis is counting by tens, but neither axis is starting at 0. So we do want to pay attention to those start values here because that's really going to impact my ability to just estimate my y-intercept, for example, from the graph. So that being said, I'm going to go ahead and I'm just going to sketch in what I roughly think a line of best fit for this data set might look like, which is kind of tough for me to do digitally here, but we'll say maybe it looks something like this, maybe a little less steep with this cluster here. And so what I want to do is I want to figure out my slope, which is really, again, rise over run. And then I want to find my b, which is my y-intercept. But like I said, I can't just trace this line to my y-axis and say, okay, my y-intercept is going to be about 5, because it's not. I'm crossing here at 5 on my y-axis, but my x value at that point is 400. So that's not going to give me my y-intercept. So what I do want to do is I want to estimate my slope. So I can just pick a couple points on the line that maybe intersect at good values. And if you had a grid, it might be a little bit easier here. I'm trying to see, like maybe if I'm at 500, I'm right around 30. So my x value of 500 is roughly 30 for y. And then if I find another point, maybe let's see, if I go up here to 900, maybe at 900, I'm at about 80 if I trace back over to my y-axis. So my slope is rise over run. So vertically, how far apart are these points? Well, I'm going from 30 to 80. So vertically, they're 50 units apart. Run, how far apart are they horizontally? Well, I'm going from 500 to 900. So that's about 400 apart. So then I can just reduce that. I've got 5 over 40, which I can reduce even further. I can make that a 1/8 for my slope. And so I'd be looking for an equation that was something close to y equals 1/8 x plus some y-intercept. And then what I can do is I can think about, okay, if this were to continue backwards and if my x-axis were extended back this way, my y-intercept is definitely going to be negative, because I'd be crossing beyond, the origin if I were to extend that back. But maybe I need to be a little bit more specific than just roughly 1/8 for my slope and then some negative number. Maybe that's not quite enough. Well, then I can go ahead and I can solve for what that y-intercept might be, because I know my slope, or my estimate for my slope. And then I can just pick an x and a y value to solve for what that y-intercept would be. So say I pick this last point here and I say, okay, y is 80, slope is 1/8, and then my x value is 900 plus b. And I want to figure out what that b is. Okay, so this is 80 equals 900 over 8 plus b. And then I can just subtract the 900 over 8 from the other side. And I can just do that roughly as a decimal value using my calculator, because again, this is just an estimate. So this is really 80 equals 112.5 plus b. So if I subtract 112.5 from 80, that gives me negative 32.5. So my equation would be y equals 1/8 x minus 32.5. So I'd be looking for something close to that equation. But again, finding an exact match to my estimate is not likely. But we should definitely have a positive slope. We should definitely have a negative y-intercept. Okay, so then we can also see other forms of equations. So we just looked at the linear equation in the last one. But if you have something that's a parabola, so a lot of times this would be like a ball is thrown in the air, or you have this projectile object and you want to find its maximum height, or you have a pendulum swinging and you want to find its minimum height. That maximum or minimum value is the vertex of that parabola. So if you have an equation that's written in vertex form, your vertex comes right from the equation. So here you see the HK for that ordered pair. That's coming from the number with x is the x coordinate of the vertex. The number outside of the parentheses is the y coordinate of your vertex. If you had something that was in standard form, so ax squared plus bx plus c, remember from algebra 2, you learned that the x coordinate of the vertex is the opposite of b over 2a, so you could solve for it that way if you needed to. Or if you have something that's in factored form, so a lot of times that would be written as like x minus p times the quantity x minus q, your x-intercepts are equal to P and Q. So that's where your graph will cross the x-axis here and here. And then your vertex is halfway between them. So the x-coordinate of the vertex would be P plus Q divided by 2. So you could find that x-coordinate, and then in both of these cases, you could just plug that back into the original to solve for y. Okay, so the other things that we should be aware of are our x and y intercepts. So x-intercepts are where your graph crosses the x-axis. So you can find those by setting y equal to 0. And then your y-intercept is where x equals 0. So you can, again, find those by setting x equal to 0. Usually in something like a linear or quadratic equation, your y-intercept is your start value. So if you were throwing a ball, it would be the initial height of the ball. Or if you were talking about investing money, it would be the initial amount invested. Your x-intercepts, especially when we talk about a parabola over here, these are the solutions or the zeros of a quadratic function. But again, it's where it crosses the x-axis. So for your assignment on Khan Academy, you have scatter plots and key features of graph.